doing great today. It's gloomy outside, it's raining today, but you and I are here. Now we are going to talk about a problem in statistics. For those of you who do not know me, hello, I am Dr. Nandi and I frequently lecture on statistics live. I also solve problems on statistics in my YouTube channel. I have solved all kinds of statistics, algebra, math problems. So please check out my channel and subscribe to it by hitting the red subscribe button. So let's get started on this problem. It says the mean pollutant concentration is 36.92, should be at a certain place, and the standard deviation is 11.34. The units for pollutant concentration is parts per million. Assume the pollutant concentration distribution is bell-shaped in nature. What can be said about the percentage of distribution between 14.24 and 59.60 parts per million? Okay, so this sentence is important. Assume the pollutant concentration distribution is bell-shaped in nature. So let's do a probability. This is not good. Probability distribution of pollutant. Probability distribution of pollutant. And they said it is bell-shaped in nature. Okay, this is equally bad. So I'll get rid of it. Let's see if I have better pen to write with. Okay, we'll try this one. Okay, so let's do the probability distribution of pollutant, which is bell-shaped in nature. So usually on the horizontal axis we have groups of data. So the pollutant concentration distribution is bell-shaped in nature. That means it looks like this. There is a center where the peak is the highest. So pollutant concentration on the horizontal axis. In parts per million, ppm. The mean is where the peak is the highest. Remember, on this vertical axis we have relative frequency or probability. Relative frequency or probability. At the center the peak is the highest. And that value is the mean. Okay, mu is the mean, is equal to 36.92, and the standard deviation sigma is Greek S, standard deviation. STD stands for standard deviation, is given as 11.34. Okay, so that is the information that is already provided to us. We haven't been told, like we have been asked to find out what can be said about the percentage of distribution between 14.24. You understand, 14.24 will be on the left of the mean because numbers decrease in this direction, and 59.60, the upper boundary, will be right of the mean. This is because the mean is 36.92. 14.24 is less than 36.92. It will be on the left of the mean. So let's subtract 14.24 from the mean. 14.2, it is 36.92 is the mean. This is your mean, and your x value is given as, on the left is 14.24. So let's use my calculator. 36.92. 36, so we will do 36.92 minus the value given 36.92 being greater, 14.24 will be on the left, minus 14.24, enter is 22.68. So this 14.24 which is on the left of the mean is maybe somewhere over here, and as you can see the difference between the two is 22.68 between the mean and this number. The other number is x minus mu that is given to us. The number on the right hand side is 59.60 minus 14.24, and that is equal to 59.6 minus 14.24 is 45.36. 14.24 and 59.60, way over here someplace. 59.60. Now if you take this difference of 22.68, which is between 14.24, 22.68, okay, take this difference 22.68 and divide it by the sigma, the standard deviation. So this difference divided by the standard deviation is 22.68 divided by 11.34, and that is equal to 2. So this point 14.24 is located 2 standard deviation on the left of the mean, 2 sigma. Similarly, if I take 45, this difference, remember this difference is 45.36, this difference between 59.60 and 36.92. Take that 45.36 and divide it by the sigma. So 45.36 divided by 11. Okay, divided by 11.34. Why am I dividing? I'm dividing by the standard deviation. Let's see what multiple of the standard deviation is 45.36, and that is 4 standard deviation. Okay, so this point is located 4th standard deviation away from the mean. So one is located 2 standard deviation away from the mean, another is located 4 standard deviation away from the mean. So the total distance we are covering is 2 sigma plus 4 sigma is 6 sigma. Okay, so between 22.68 and 45.36, the difference is 6 times sigma. Difference is 6 sigma. 6, number 6, 2 plus 4 is 2 plus 4 is equal to 6 multiplied by 6 sigma. Now since this is bell-shaped distribution, according to empirical rule, almost all of the data, actually to be precise, it is 99.7%. Almost all of the data fall within 6 sigma. 6 multiplied by sigma, this is sigma. This is 6 and this is sigmas. Within 6 sigma or 6 times standard deviation from the mean. Deviation from the mean. So the answer to our question is this one. 99.7% of the data will fall between 14.24 and 59.60. Let's summarize what we did. We are told that the pollutant distribution is bell-shaped in nature with a mean of 36.92 and standard deviation of 11.34. We have been given two values, one value on the left of the mean, 14.24, another value on the right of the mean. Okay. And you know something? I did a mistake here. X minus mu, that's what I was thinking. What is the mistake? The mistake is x minus mu. Mu is, so I have to draw this correctly actually. The mean, so this value is located 22.68 from the mean. How did I get it? I did 36.92, which is this center, minus the lower value 14.24 is 22.68. Then I took that 22.68, divided it by sigma, which is 11.24, okay, 11.34. 22.68 divided by the standard deviation, 11.34 is 2. Now I take the higher value, okay, and subtract from it the mean. This is on the right of the mean, it's the higher value. From that higher value subtract the mean, which is 36.92. Okay, and that difference will be, let's do the calculation correctly, is 59.6 minus 36.92 is 22.68 also. This is important. This point is located 2 standard deviation below the mean. This point, which is 59.6, is somewhere over here, is also located 2 standard deviation from the mean. This distance is also 22.68. You take 22.68 again and divide it by the sigma, which is 11.34. So it is 22.68 is the difference from 59.60 to the mean. Take that difference of 22.68 and divide it by sigma. 22.68 divided by 11.34 is also 2. Okay, and then we will use the empirical rule. Okay, so let me write down between 22.68 and so the two numbers are 14.24 and 36 and 59.60. So this and this is 2 sigma also, this distance. How did I get it? 59.60 minus the mean is 36.92 is 22.68 divided by the standard deviation 11.34 is 2. So let me erase all of this and rewrite it again so that there is no confusion. Let's use a different pen. So both 59.60 and 14.24 are located 2 standard deviation away from the mean. 2 multiplied by the standard deviation away from the mean. Now we will use the empirical rule. Okay. According to empirical, the word empirical means observed rule. According to empirical rule, empirical means observed, empirical rule for bell-shaped distribution, this is important. It has the distribution, probability distribution has to be bell-shaped in nature. For bell-shaped distribution, approximately 95% of the data, 95% of the data, this is important, this is your answer, of the data will fall within 2 standard deviation from the mean. Within 2 standard deviation of the mean. 2 standard deviation of the mean. Standard deviation from the mean. So the answer to the question, what percentage of the data will fall within 2 standard deviation from the mean. So let me erase that. Will fall within 2 standard deviation from the mean. So the question was what percentage? What can be said about the percentage of distribution between 14.24 and 36.92? We already established both 14.24 and 36.92 are, and 59.60. This is the point. 59.040. So both 14.24 and 59.60 are located 2 standard deviation away from the mean. According to empirical rule, approximately 95% of the data will fall within 2 standard deviation of the mean. The empirical rule applies to bell-shaped distribution, which is true in this case. That means between 14.24 and 59.60, 95% of the data will fall. Okay, that is the answer to the question. So we first found out what is the distance of 14.24 from the mean, which is 22.68. Took that distance divided by the standard deviation of 11.34 is 2. So that point is located 2 sigma below the mean. Then again take the difference of 59.60 from the mean 36.92. That is also 22.68. Divide that by the sigma. The distance is 2 sigma away from the mean. The point 59.60 is also located 2 times sigma away from the mean. So according to empirical rule, at least or approximately, not at least, approximately 95%. The key word is approximately. Approximately 95% of the data will fall within 2 standard deviation of the mean. In this case, between 14.24 and 59.60. I stop here today. If you have any question, comment, please do not hesitate to write me a note and I'll get back to you as soon as possible. If you like this video, please give me thumbs up. I really appreciate that. That motivates me to produce more interesting videos just for you. I stop here today. I thank you for taking the time to watch my presentation, and please do not forget to check me out tomorrow. Please subscribe to my channel by hitting the red subscribe button, and please do not forget to click on the bell button, which will notify you every time I upload a new video. So please let me know where you are watching from and if you like this video or not. If you like it, please give me a thumbs up and subscribe to my channel. Thanks again. Bye bye. Take care. Have a nice day.